Okay, today we got hard problem 3027, find the number of ways to place people 2. So we are given a 2D array of points, right direction, left direction, up, down, whatever. So we place n people, one person at each point. Alice wants to be alone with both. Damn. You go, Alice. Damn, Bob will be happy with Alice. Anyways, so they build upper left. Wait, what? With Alice's position upper left and Bob's upper left and lower right. Might not, it can be a line. Alright, I mean, I don't understand why this is a line here, but okay. So she will be in upper left and he will be in lower right. Okay. Okay. Alice cannot build either of the fences in the picture below with 4 corners. Either of the fences in the picture below. With Alice at 3-3. I mean, they said it can be a line. But okay, whatever, I guess. Okay, so, and what do we do? Return number of pairs of points where you can place Alice and Bob such that Alice does not become sad on building a fence and she becomes sad if someone is inside. Okay, and 1000. All the points are distinct. Points I, okay. So essentially what we need to do, let's say we sort the points, and of course this screams that it wants quadratic. So what we do? Well, we start with this point, right? And then we iterate by x, right? Because and then we want the points that are what? Smaller than or equal to us, right? And then we make sec3 over y of points we have already met. So the points, we are only interested in the points that are between us, right? So, okay, we process this, and let's say there would be another 5 points somehow here, right? Then we would go a point here, and we would have one here already. And we would query from here to here, and whatever, right? Check if there is something. If yes, we are cooked. We mark and we move, and that's the whole shtick. So we solve in n log n for fixed point, so n squared log n. I guess that passes. Maybe they want n squared. Not sure if I can get n squared, to be honest, but Yeah, I don't know, but I can do a sec3, so let's do a sec3. Do that. Typos. Let's see, last time I did sec3 and some problem on here. I had some typo, but we'll see, we'll see. We will see. Anyways, that should be a sec3, and now okay. I mean, you don't really put that before that, but whatever. So we sort the points, and then I can prettify these two, I guess. Okay. Okay, and now, okay. ST. No, I have to compress the points. That is compress the y coordinates actually. So y. Okay, and sort y begin, y end, and that's unique. So I sort and then I unique, y begin, y end, or is it like y resize, unique, y begin, y end. Like that, maybe. I'm not. I have no clue what I'm doing. Okay, I checked and it's. I almost got it. So y erase, and this is obviously y end, and then that's like, I don't know, val yi is equal to I, and then we get to the real shit. Okay. I mean, you obviously want to start from the next point. Okay, how is it with ties? Because, you know, let's say they are the closest in X. Okay, well, it will probably go from the smallest Y. So you don't really want to sort like that. Oh my god. Outer pair 1, outer pair 2, return P1 first, or whatever, no. P1 0, P2 0, P1 0 over 1. Otherwise P1 0, P2 0. So this way we go from, like, even if we have ties, we go upwards. So at some point we get to 1 here, and then we might stop if we are on the same. So, or stop, or at least it will work. So okay. So first, okay, so we don't really care about the x, we only care about the y. So int y1 points I1, no, val of that, nice, and then int, oh shit, points j1, great. And now we want what? So if y2 smaller than or equal to y1 and st query so from y1 to y2 to y1 plus 1, okay, and so I guess that's fair. The query is 0. Then we do as plus plus, and finally we do st update position y2 with 1. Okay, let's see what's wrong. So n is undefined, great, so I swapped it. Oh my god, it works immediately. Ain't no way, dude. I am a genius. Let's go. That's crazy, but apparently quadratic is possible, so. Oh my god, bro, what the hell? That is crazy, dude. I mean, okay, let's try to think about a quadratic solution, not quasi-quadratic. So at some point, okay, we go through whatever, because the valid points, right, with this would make a decreasing sequence of y's. So let's say first we process this guy, right? Then obviously the next ones have to have smaller y value. Okay, so okay, we can erase all this. because we are of course not gonna need it because I coded it. And now let's see, we don't need a sec3. And then let's say last y, and let's let it be like, I don't know, 1 in 9 plus whatever. Let's do inf, and let's do like constant inf 2e9, who cares, right? So that's y2. And now if this holds and last y infinity or y2 last y ans plus plus last y y2, and then we don't need it, and I think that's it. What do you mean? I'm quadratic, bro. Okay. What the frick, dude? Okay, so this sorts the points, and now I mean the point is not gonna have same x. Maybe it can have the same x. I guess it can. Let's say so we want to do this. Last x points j0, and now if then let's see. It's really annoying that I'm just now I got the wrong answer in half the cases. That's amazing. I mean, the points are now inverse, so I take a point. So this is my first point, so that's first point, and then okay, let's see what. Oh, come on, man. Ain't no way, my brother. I forgot about prefix sums. Bruh. Then of course I'm not beating that. Okay. Okay, whatever. Okay, of course I'm not beating anything. Okay. Sorting plus counting. I'm gonna steal their names. So if we sort the points and fix Alice, how to check all other points if they can be if Bob can be there. If Bob can be there. If they are we pre-sort the points, we only have to check points that are that have the x coordinate larger than or equal to Alice's x coordinate. If we sort ties from by decreasing y coordinate, simply iterate over the points until we find the first point, the points with greater than or equal to x coordinate, until we find the first suitable smaller than or equal to y coordinate. Next suitable point will have a larger y coordinate value if there even is such, but still smaller than or equal to the Alice's y coordinate. Therefore we just keep track of last Bob's y coordinate. That's it. on squared, since we first sort the points in on log n and then iterate over all pairs of points doing O1 work for each of them. Note that if you do a solution with prefix with 2D prefix sums, you avoid the sorting and achieve a faster solution in practice. And that looks weird. O of 1. We do not store any since we only use a couple of extra variables. Okay, but how do they do only ON memory? Okay. Coordinate. What do you mean discretization? The values are already discrete. Coordinate compression it's called. Okay, let's see. So whatever. Oh, wait a minute, brother. That's n squared. What are you yapping about? That's crazy. You motherfucker. You are lying. You are simply fucking lying. Surprised there was not a monostack solution. Here is the one I came up with myself. I mean, that's still n squared, so who cares? I mean, yeah, but you are sorting, so... And still, this is wrong. This is wrong. What? You are doing n squared? Okay, just shut up. And what's YON? What? Extra space sorting? Oh my god, goodbye.